You can do better than that. Congrats to our footballers, by the way, for not losing yet. Woo!
Yeah.
Oh, woo! I saw your Instagram.
Yeah, I know. I was there in spirit. Which is what I will be again this weekend, because I'm not traveling that far. So, here we go. Especially to watch you guys lose. Predicting it now. So, vectors, let's talk about it. Skip the first half. We did this before. So, if you're just hanging on now, great. Awesome. So, here we go. 3, 2 is a vector. Now, remember, vectors are movement. It's this idea. It's not something that's planted somewhere specifically on a graph. It's something that can happen 2 points on a graph, though. So, the vector 3, 2, choose a random starting point. Okay, I'm going to choose this guy. It says 3 to the right and 2 up because we have a horizontal component first, vertical component second. So I go 3 to the right, 1, 2, 3, and 2 up. And there is the vector 3, 2. I can put that vector anywhere. Copy and paste. You can even put it on the origin. Are we good? Yes. All right, cool. So that's vector 3, 2. I'm going to call it something. Let's call it vector B for Brainerd. What?
Why'd you say we were going to lose?
Because we are.
I'm predicting that you will.
A prediction's not an accurate assumption.
I believe in you guys. I do.
He believes in them.
I hope you do. I really
Wait,
do.
we're going to call it?
No. So vector V for Brainerd. Remember, vector symbol is an arrowhead, but only half of it. And I called it B because I wanted to. That's that vector. 6, 4. This vector. I'm going to plant it right here. 6, 4 means 6 to the right. 1, 2, 3, 4, 5, 6, and up 4. 1, 2, 3, 4. So that's the vector that takes any point from here to here type of deal. We'll call that vector C. I don't know why. Cool. Now, are these vectors going to be parallel? Yes. The reason for that is their components, when you put them in a ratio, 3 over 2 and 6 over 4, are going to be equal, right? And if the components are equal in a ratio, then they are parallel. Cool? Awesome. So if you notice, 3, 2, and negative 1, negative 2 aren't going to be parallel because 3 over 2 is not the same thing as 1 over 2, right? So they're not going to be parallel. Fun fact. Finding magnitude. Magnitude is the size, right? And size matters, unfortunately, for Danny Mao. These two vectors are not the same because they're different size, although they are going in the same direction. So how do we tell how long they are? Well, we can measure them by doing distance formula, otherwise known as the Pythagorean Theorem, right? We can make a little right triangle here, and of course it's 3 across and 2 up because that's its components. And this guy is 6 across and 4 up because, again, that's its components. If we do Pythag, we can figure out how long this is. 3 squared plus 4 squared added together and rooted. We get this. 3 squared, 2 squared, rooted is going to get us the magnitude of vector B. 3 squared is 9, 4 squared is 4. We add them together, we get 13 rooted. So the magnitude of vector B is root 13. The magnitude of C is going to be bigger because it's bigger. 6 squared and 4 squared, all rooted. What we're going to get is the magnitude of vector C. Well, 6 squared is 36. 4 squared is 16. That's going to be 52. So root 52 sounds like a fun place to drive. That is the magnitude of C. Magnitude of size. You got to do it for all of them. Am I going to do it for all of them? Hell no. That's for you to do. Turn the page. Page number 2. Translate by the given vector. Translate means to slide.
Move it up.
So here's what we're doing. We're translating by this vector, meaning everything's going to go to the right 5 and up 9. If I start on A, I go to the right 5. So that puts A at 7, comma 6. That's the vector. And that same vector we're going to copy and paste to C and B, 5 to the right, and 9 up. There's C prime. I'm not going to do it for B because I'm lazy. There's A prime. And then you'll draw on your triangle after you do it to all 3 points. The rule here is that we're taking our original coordinates, x, y, and then we are adding 5 to the x and adding 9 to the y. That's the rule.
Wait, so what is that? How do you find your primes real quick?
So the vector says 5, 9, right?
Yeah.
So we're going to go 5 to the right, 9 up. Cool. So 5 to the right, 9 up for all of these. You'll do it for B as well, but I'm too lazy to do it. Take that vector, copy and paste it. Bam. I think it's somewhere around here.
Dig, boy.
Boop, boop, boop. There's your triangle. All right. Questions on sliding things.
Okay, that's not bad.
Translations. How do we feel about sliding images?
I'm fine with sliding.
Cool.
Just add or
All right, so the next thing we're going to do is instead of us saying, hey, what happens when you slide it by this vector? Oh, it does that. It's going to say, look, I already moved it. Tell me what vector I use. That's what this guy is, right? So how do we know where we start and where we end up? Which one's which?
A to A.
Yep, A to A prime. We're always moving towards prime. Prime means new. So we're doing this to get there. In fact, we're using the same vector for all three because this is a translation. Translations use the same vector for every point. We slide it all the same. So how do we figure out what vector that is? Well, we're talking about its components. If we're starting on A, it looks like we head left 1, 2, 3, 4, 5. So left 5, that's the horizontal component. And then up 3. So there's the vector we use. Yay! Yeah, it's going to be the same for all of them, right? B is 5 to the left and 3 up, right? Same thing for C. If it's a translation, they're all going to be the same. Right, so I'm going to go back to the beginning, and we're going to fast forward through all this stuff to review it. Here's the first page. How do we feel about drawing vectors?
not good.
Okay, so if I were to graph this one in pink, -1, -2, I choose a random spot. I don't know, let's choose the origin.
Okay.
Left 1, down 2.
Yeah.
You could graph it there, you could graph it here, you could graph it here. It doesn't matter where you graph it. They're all the same vector.
You're not making a point to where your new coordinate is.
It's
You're just
nah.
drawing a line to it.
Yeah, exactly, an arrow.
All right.
The arrow is the vector. Vectors are about movement. They're not coordinates. That's why they have the pointy brackets. Okay, so all these are the same vector. Let's call them vector T for Thomas. When we want to find out if they're parallel or not, well, if we compare these two, they're not going to be. Because 3 over 2 isn't the same thing as -1 over -2. Is -1 over -2 the same thing as 6 over 4? No, so they're not parallel. What about -1 over -2, 4, 8? They are the same, right? That's a half, that's a half. So they'll both be parallel. So that's fun. Cool?
Cool.
To find the magnitude, we do Pythag. Square, square, and add, right? That's the magnitude of vector T. Pythag, everybody cool with that?
Yes.
Katie? Yes? -1 squared is 1. -2 squared is 4. Hey, look, it's root 5. That's the magnitude of this cube. That's right, vectors. The direction is the components. The magnitude is the distance. Turn the page. Remember this one? It told us that we needed to move everything 5, 9, right? If that one of those was a negative, like if that was a -5, it'd be left 5 instead of right 5. Is that blowing anybody's mind? Move it 5, 9. Okay. This one blowing anybody's mind? -5, 3. Awesome, that's half the quiz. Next page. I'm going to give you a couple minutes to do this. Not the definitions. You need to do that from the notes. Notes are online in color, or I handed out a color, black and white copy last time I saw you. Again, on Google Classroom in color if you want them. Draw a vector, label it, find the magnitude, find the components. So let's draw a random vector. I'm not going to do it because if I do it, you'll just copy mine. So draw your own vector wherever you want. Make up your own crap. Tell me the components. So you're going to tell me this, right? You're going to name it something. Vector P. I don't know. And then find the magnitude. How long is it? Get creative. Give you a couple minutes to do that. I'm going to walk around. If you need help, raise your hand or flag me down.
Let's see what I can use for a reference here. So is it 2
You're
points
making
and
it,
goes through it?
your, yeah.
I have a question on.
Isn't it good? Sure.
Why come in at homeroom and get this done when you do it right now?
I asked you for this part. I'm doing this part right now. Maybe. Well, I was gonna ask you for this.
Well, that's when you write them in a ratio. So 3 over 2 does equal 6 over 4.
Oh, shoot, no.
Alright, so draw vectors. Pick any 2 points to start and end on. Yeah, it's the game.
Not a bad thing. People dropped out and made names.
Cool. Now draw your arrow.
My parents,
Arrow.
about school, they didn't go anywhere.
Actually matters because this is one that.
You see these
So
kids
we're
that
heading
dropped
this
out of high
way,
school.
and we're going left. How are we going?
You guys,
Going down.
you guys went
What is- what's
to
the,
year college after high school. And we didn't.
You know what you're
Negative 4, negative 6, right? So you write that in these brackets.
Oh,
What do you write? Negative 4, negative 6.
Wow!
Yeah.
How high is it cut?
You have to make another one.
Yeah, no. Negative 4, negative 0.
Your starting point?
Yeah. And then you're going to do your Pythag with those numbers to figure out how long that is.
And then you gotta make another one.
You wanna
Yeah.
talk about it? Am I right so far?
You went over 3 and up 4, yeah, it was good me. Except over 3 up 4.
Depends how sad is it. Oh, okay.
Carpenter, are you coming to my homeroom today? Carpenter, are you coming to my homeroom?
Oh, the magnitude. Ah.
Yeah, find magnitude. Pythagorean Theorem. I'm going to give you one more minute to do Pythag. How's it going? How are you?
Good. Answer it.
Shut up, Brooke moved years ago. I think she moved, Jacob, otherwise I don't think you, he's busy, I won't interrupt.
Sure, whatever.
Jesus will be friends. That's
And then
hilarious.
you had to
I've never heard someone call someone.
That's hilarious.
Justice, are you done with your stuff?
What? Yeah.
Awesome.
We're mint. We're mint.
Cool.
Oh, good heavens.
All right, here's my vector. I'm calling it vector P. Let's figure out what its components are. Well, horizontal component comes first. So going from here to here, I traveled 1, 2, 3, 4, 5, 6, 7, 8 to the left. Or I'm sorry, 8 to the right, so that's positive. And I traveled how much down? 1, 2, 3, 4, 5. So that's minus 5. That was mine. If I want to find the magnitude of vector P, then what I do is I do Pythag with the components, right? Here's my A, here's my B. So negative 5 squared plus 8 squared rooted is going to be the magnitude, because that's Pythag. Everybody cool with seeing that that is Pythagorean theorem? Do we see that this is Pythag? A squared plus B squared equals C squared, but it's rooted? Cool. So this is 25. That's 64. That's going to be 90. Oh, no, it's going to be 89. Root 89. So that was my magnitude. Questions on that? Do you feel like you could do that on your own? How'd it work for you? What did you struggle with the most?
I didn't even get to the feedback yet.
Why not?
I'm slow.
So my thing equals the square root of 200. Nice.
Cool.
I just did that all in my head too. I'm proud of myself.
Wow.
What?
Is that done?
Yeah, it's done. That was it.
Second part, I have a question.
I understand that.
So when I hit my number, I got 25 just like you. What do you think the addition?
Okay, so what we're doing is we're figuring out the length of this vector. And so what I do is I make it into a right triangle.
Exactly what I did.
We just looked over it.
And notice that the legs of the right triangle are going to be your components. Negative 5 and 8. So I do negative 5 squared plus 8 squared equals this guy squared, right? Right? So negative 5 squared plus 8 squared, all rooted because I want regular C, not C squared. Right? And C is going to be the length. Yo, go. So that's where the plus came from. A squared plus B squared.
I guess.
Yes?
Yes.
Awesome.
Yeah. Make it-
All right, what if I told you this was going to be on the quiz?
Bad.
I would shit myself.
Okay? Why? See?
I
Great, let's work with that. Why would you do that? What part of this would make you do that?
Probably like understanding the stuff to the right.
So this stuff.
Fact.
So we're good on this. If I cover this up, we're good on this.
Yeah, you just have to count. That's it.
Awesome, excellent. So we know that the horizontal component comes first, so it's going to be the left to right part first. Excellent. So I want to figure out how long this is. That's the magnitude, is the size, right? So to figure out the size, what we need to do is we need to break it down into its components, because we can't just count the squares here. So what I do is I do Pythagorean Theorem. What's Pythagorean Theorem, Justice?
A squared plus B squared achieve that.
A squared plus B squared equals C squared. A is -5. B is 8.
Okay.
So when I do that, I get this.
-25, 25 plus 64. We're good. Okay. All right, we're good. I processed that.
Thank you.
Yep, we're good.
What?
Were we supposed to make a parallel?
No.
Do we have to do that for the quiz?
No.
This is different than the first page.
Really,
Well, okay.
This one was just draw a vector. Some of you guys overachieved and drew 2 parallel vectors.
Yeah.
Yeah. Reading is hard, math is easy. All right, so questions on this?
Yeah, I still don't know how you got 60.
No, I think.
You don't know how I got 64? Well, from here, did you follow me up to here?
Yeah, and then,
8 times 8.
Yeah, I took it out.
so.
-5 times
-5 times 5, -5.
She sat in the back of the classroom.
Better?
They're 2 different things. Okay. You know what?
No. Are you better now?
Yeah.
For real?
Yeah.
Okay. Again, the reason we're doing this is so you can ask the dumb questions. The dumb questions are the one that have really simple answers, right? And I'd rather answer those than have that thing trip you up,
Yeah.
right?
Unlike you.
Seriously. All right.
Why do you flip it up like that? It's just.
Aw, man.
That's a big old freaking.
All right.
See, I'm a glass.
Now we're here.
Big old one side.
Reflections. Get it out.
I think so.
We did this in class last time.
Yeah, let's try to grab it out first.
Here's what I want you to do. I want you to not write down anything, absolutely nothing as I go through this. Some of you, okay, what?
Is this what's due? Is this?
That's one of the things that's due Friday, yes.
Is this the other thing?
With the definitions on there too.
So don't even get the paper.
Rainer, ball.
Ready? 3, 2, 1. Fireball. That was nice.
Andre, figure it out. Get this out. We did this last time. I don't want you to write anything down. Absolutely nothing. Okay? Nothing.
Yep, it was.
I didn't even get it out, so.
Excellent. Perfect. I will let you write it down after I'm done. Okay? Here's the deal. You're going to watch the show. You're going to learn it, and then you're going to write it down. Everyone wants to write it down because they think, if I don't write it down, I'm not going to memorize it, right? I'm not going to remember it. Well, no. You're right. Writing it down does help with memorization, but memorization should come after learning because it'll be easier to memorize if you understand what it means. Right? If I give you a bunch of random symbols up here, it's going to be hard to memorize all those. But if I tell you, like, look, all those random symbols are really just the alphabet turned upside down, super easy to memorize now, right? So, well, not backwards, just turned upside down, like A flipped upside down, B flipped upside down, right? It's easier to memorize stuff if you know what it means, if you have context. So we're going to get some context, and then you're going to write this crap down, and you're actually going to learn it. The one thing you really learned how to do in school, and really the only thing you learned how to do in school, is to write crap down. But here's the thing. You write it all down, and you don't study, so what's the point of writing it down?
True.
I ask you, right? So how about we just screw all that and just learn?
Yeah.
I don't know. Let's try it. Let's try it. Let's just try it. What do I know? I'm just some guy, okay? But I don't know. Makes sense to me. Number 3 we already did together, okay? Which is great. You really have no reason to write this down. And if you weren't here for it, fantastic. Write it down when I'm done. Don't touch your pencils. Watch the show, okay? So, what we're going to do is they want us to take this point, 5, 3, and flip it over that line. So first off, I'm going to draw the point. It's 5, 3. 1, 2, 3, 4, 5, and up 3. I'm going to call that point A. Again, this should feel familiar. We did this before. And if you weren't here, great. Y equals x is the line we want to flip it over. Now, this line is a little tricky because it's so simple. Another way to think of that is this, right? I think that's easier to understand because now we can see clearly the slope is 1 and the y-intercept is 0. Slope-intercept form, right? No yawning in math class. 0 is the y-intercept. That means it's where we hit the y-axis. So we hit the y-axis at 0. And this line has a slope of up 1 over 1. So here is my line. It's okay that it didn't go through A. Remember, that's not the point. We're drawing the line of reflection, the line that we're going to flip it over. So once I have a pretty good understanding of what that line is going to look like, again, the more accurate, the better, I'm going to draw that line. Ah, wonderful. So there's the line. Questions on that so far? No, because you're watching and you're learning. At least some of you are. Yeah, how's that been working for you this year? It hasn't. All right, so next we're going to find the line that's perpendicular to that. Now, perpendicular lines have perpendicular slope. Not the same slope because that's parallel. So how do we get perpendicular slope?
You flip it.
You flip it and?
Negate it.
Change the sign, exactly, negate it, right? So if it's 1 here, we flip it, we get 1 over 1 flipped is still 1 over 1, but it's going to be negated. So we change the sign. It was positive, now it's negative. Awesome. Now we don't know what the b value is. We don't know that. We have to go look for it, right? Y equals mx plus b, right? We got to find that guy. Well, how do we know? Well, here's the thing. A line that's perpendicular to this guy could be any line, right? Here's one that's perpendicular. Here's one that's perpendicular. What we want is the one that goes through A. So we need to plug in A into here to figure out what B has to be to make that happen, okay? Again, when a line goes through a point, it's telling you that that point is a solution, meaning that if you plug in 5 for x, you should get 3 for y in its equation. Brainerd, stay with me, okay? So what does B have to be? That way when we plug in 5 here, we get 3 there. That's what we're trying to figure out. So I'm going to plug that in right now. 5 goes into the x, 3 goes into the y, 3 here, 5 here. And now we're going to find out what b has to be to make this statement true. Negative 1 times 5 is negative 5. And then we add 5 and we get 8. So b is 8. That's what b has to be so that it goes through this point. So our perpendicular line is going to be y equals negative x plus 8. Again, negative x is the same thing as negative 1x, right? I just plugged in 8 for b. Go. So now I'm going to graph this line. We know how to graph it. Y-intercept at 8, which means it crosses the y-axis at 8. David, you with me? 1, 2, 3, 4, 5, 6, 7, 8 is where it crosses. Negative 1 over 1 is its slope. Of course it is, because it's the perpendicular slope to this, right? Instead of going up 1 over 1, we're going to go down 1 over 1. When I do this, look, it does go through A, which is what we wanted. A perpendicular line that goes through A. Now, why are we doing this? Well, we know that when you look at a mirror, your reflection is going to be right in front of you, right? It's not at some weird angle. Directly in front, meaning the reflection of A is going to be directly in front of it. It's going to be somewhere on this line. The question is, where on this line? If A moves back further, then the reflection of A is going to move back further, right? If I look in the mirror, right? If I look in the mirror, mirror me is just as far away from myself as I am from the mirror. So from here to here is the same as from here to mirror me in the background, right? You can't see him. He's good looking, trust me. If I move closer, he moves closer. If I move farther away, he moves farther away, right? So we know the distance between here and A is the same as between here and A prime. So you can kind of eyeball where A prime is going to be. It's going to be like right here when you reflect it, right? Now we're not going to eyeball things because looks can be deceiving. Here's what we're going to do. We know that those distances will be the same, right? However far A is from the line of reflection, A prime will be from the line of reflection. So in other words, this point right here is the midpoint between A and wherever A prime is going to be. You dig? That's the idea. So what is that midpoint? Well, you can eyeball it here, but again, not always are our lines going to be so nice. So we need to figure out where they intersect. How do we figure out where two equations intersect? Does anybody remember from last time?
Find the average.
Nah, not quite. Here's the idea. We want to know where these equations both agree, where they intersect, right? Where they both have a solution. In other words, where they equal each other. Notice that y equals this and y equals that. Well, if y equals both these things, shouldn't these things both be equal? If y equals this and y equals that, this equals that. So the blue equation, negative x plus 8, should equal the red equation, x plus 0, otherwise known as x, right? Cool. So now I get my x's together. Terrible idea in real life, great idea in math. And I divide by 2, and I find out x is 4. That tells us they intersect at 4 comma something. Yes.
If you get both your axes, shouldn't that be 0? Because you put a negative 1 and a...
I added the x to this side, so it's 2 x's. Right, it was negative, so I add it to move it over. What's x plus x? 2x. Cool, it's cool. And then I divide by 2 and I get this. So x is 4. How do I figure out what y is? Well, I can plug it into any of my equations, right? So I'll plug it in here. If x is 4, what's y? Also 4. That's convenient. So it intersects at 4, 4. It do. Wow, wow. So our midpoint is 4, 4. A was what they gave us, right? This point, they said it was 5, 3. We're going to look for A prime where it reflected. What is midpoint formula?
Half the average.
It's the average of the x's after the y's. When we average stuff, do we add or subtract? We add things. It's okay. So we're going to add our x's, and we're going to divide by 2, the number of pieces, right? Let's do this in our head. Actually, no, let's not do this in our head. Not yet. The midpoint they gave us, it's 4, 4, right? Awesome. Now, we know one of our points, it's 5, 3. The other one we don't know. We're going to call that x and y, right? M is the midpoint between A and A prime. So we're looking for these guys. We know that this part should equal that, and this part should equal that. So check it out. Let's solve in our heads. We're going to get x on its own. How do I get rid of divide by 2? Multiply by 2. When I multiply by 2, what do I get over here?
Oh, you beat me to it. He was in the bathroom way too long.
All right, I lost you on the last 5 seconds. Wake up. Look back up here. These two are equal. So now I need to solve for x. There's x. Let's get it on its own. How do I get rid of divide by 2? Times by 2. So that's not a 4. It's now a 8. Subtract 5 to get rid of the plus 5. And now I have a 3 over here. So x is 3. So I found out my coordinate. X is 3. So that's this here. A prime is at 3. Now for this one. Times by 2. 8. Subtract 3. 5. So y is 5. And that's where A prime is going to be. Check it out. I'll go back. 3, 5 is A prime. 1, 2, 3. 1, 2, 3, 4, 5. Perfectly reflected across. Same distance on both sides, perpendicular to the line of reflection. Now this seems like a lot, and it is, but it'll be less if we think in steps, and instead think of in concepts. Okay? Here's what we're doing. We graph the original line. Yes?
What if you plugged in 4, 4, 4, x to line?
So the midpoint goes here. If you plug it in over here, it's telling me that that's one of the endpoints. So what you're going to get, Haley, when you do that, is you're going to find the midpoint between A and M, which will be here. You see what I'm saying? Okay, good question. All right, bring it back. We graphed the original line and all that entails. We found the perpendicular line and graphed it. Then we use midpoint to find out where A prime is. That's what we did. We graphed the original. We graphed the perpendicular. Then we use midpoint to find A prime. That's what we did. Does everybody understand those 3 things that we did and why we did them? That's important. How do we do them? We found the original line. We said, look, y-intercept at 0, slope at 1. There it is. We found the perpendicular line by flipping and negating the slope, then solving for b. We plug the point in, right? We graphed that one. We found where they intersect by setting them equal to each other and solving for x. Then we found y. It happened to be the same thing, right? When we plug in 4 for x, we get 4 for y. You could have plugged it down here too. What's negative 4 plus 8? 4, right? So we still get 4 for y. There's our midpoint. Midpoint, endpoint, missing endpoint. Remember that from a quiz a long time ago?
Yes, I do.
Oh, God.
We had this, right?
I got bum rushed by that.
We knew these. We're looking for this. So we plugged in one of our endpoints, and we plugged in the midpoint. We solved for the other endpoint.
Oh, yeah.
How do you feel?
All right.
Decent? Do I have you at 50? Keaton, do I got you at 50? David, we're going to do another example. Number 4. Here's what we're going to do. The 3 things. We're going to plot our original line and our original point. We're going to find the perpendicular line that goes through that point. And then we're going to use midpoint to find the reflection. Plot the point. 2, 1. Don't write it yet. Watch. I'm going to go through it fast. Watch for the ideas. Trust me on the math. 2, 1 is the point. Graphing this line. Negative 2 is the y-intercept. My slope is down 2 over 3. Here's my line. This is the line of reflection. Brainerd, don't be obnoxious. And stop writing stuff down. Thank you. Yeah, but that's not going to help. So I graphed the original line. We cool? Do you see how I did it? Down 2 for my y-intercept, and then down 2 over 3 for my slope. Yes? Awesome. Now I'm going to find the perpendicular line. Well, the perpendicular line is going to be perpendicular slope, so I'm going to have flip and negate, 3 halves. How do I solve for b? Plug in the point I want it to go through, right? What does b have to be to make it go through that point? Let's do math. 3 halves times 2. Well, that's 2 divided by 2, which is 1 times the top, 3. You could have also done 3 times 2 first and got 6, and then divide by 2 and got 3. Subtract 3, turns out b is negative 2. So our line that we want to graph is this. We know how to graph that. Down 2. Oh, look. That's where we start. Up 3 over 2. Look. That's where we end up. That's convenient. So here's the perpendicular line that goes through that point.
Ah, I see.
Now, we need to figure out what the midpoint is. We've got A, that's this, right? If we know the midpoint, then we can use midpoint formula to flip A over to A prime. So how do we figure out where the midpoint is? Well, it's where the 2 lines intersect. How do we figure out where 2 lines intersect?
Average.
No.
I don't know.
It's okay, you don't remember. It's something we looked at just now. We take the original equation and set it equal to our other equation. Where do these 2 lines equal each other is what we're asking, right? Where do they intersect? And we said it was 3 halves x minus 2, right? Now trust me on this. If I add 2, move the 2 over by adding. What's negative 2 plus 2? 0. So both those negative 2's cancel. And I get this. I'm going to add this over, and I get 0 here because I added it. I moved it, right? Nothing left over. And I have this here now. We can combine these x's. We just need common denominators. 3 halves is the same thing as 9 sixths. And 2/3 is the same thing as 4. Oh, I don't want that, do I? Yes, I do. 4 sixths. How did I do that? Times by 3 to the top and the bottom. That gets me the 6. Times by 2 to the top and the bottom. That gets me the 6. Is 9 over 6 the same thing as 3 over 2?
No, yeah.
Yes, it is. I didn't change the problem. I just made it look different. I want common denominators. Is 2/3 the same thing as 4 sixths? Yes. Didn't change the problem. That's not allowed. But I am able to make it look different. And now I can combine these. If I've got 9 sixths and you have 4 sixths, how many sixths do we have together? Now we get rid of divide by 6 by multiplying by 6. What's 6 times 0? How do I get rid of the 13? Divide. What's 0 divided by 13? Still 0. So x is 0. They intersect at 0 comma something. We could have stopped right here if you were clever and realized, hey, we have something plus something equals 0. It's going to have to be 0 for x and 0 for x. Well, I mean, if you're clever, you can think outside of the box. But if you're not, do the math. So we know it's 0 for x. How do I figure out where y is? I plug it into one of my original equations. I'm going to plug it into this one. If I plug in 0 for x, what do I get for y? Right? 3 halves times 0 is nothing, minus 2 is negative 2. So they intersect at 0, negative 2. Oh, look, they do. Now, why did we do all that? Because eventually we're not going to have the graph to go off of. And you can't always trust it. So this is my midpoint. What's midpoint formula? Exactly. When we average, do we add or subtract? We add them up. So this is the formula. What happened? Oh, my bad. So our midpoint is 0, negative 2. They gave us a point for this one. What's the point they gave us? 2, 1.
So 2.
Let's find out what our reflection point is at. So I times by 2, I get 0. I subtract 2, I get... I'll do it again. Eyes up here. I times by 2 and I get 0. I subtract 2 and I get negative 2. I times by 2 and get negative 4. I subtract 1 and get... Here's where A prime is. Negative 2, negative 5. Negative 2, negative 5. 1, 2, 3, 4, 5. A prime. What did we do? We graphed the original line. We found the perpendicular line. We found where they intersected, and then we flipped it using midpoint. Drive you at 50. Today is the day where all this feels like garbage, and you're like, oh my God, and then tomorrow it all comes together. Happens the same way every year.
Oh my God.
If you're at 50, you're doing really well. If you want, you can write this down. I don't care. Everything's made up and the points don't matter. I had some parents ask, why don't you give them more homework? Here's my opinion on that. You have 2 scenarios, right? You give a kid 100 problems or something, right? More homework. Scenario A, kid knows what they're doing. Do they need to do 100 problems? No, they don't. Scenario B, kid doesn't know what he's doing. Does he need to do 100 problems? Good God, no, right? Like, he can't even do one, right? So it's a waste of time for everybody. But you need to know your crap. Do you get the idea?
Yes, sir.
If you don't, there's day 2 tomorrow. Also, there's homeroom today. Skip number 5, we're not doing it. I'll see you tomorrow.
What are we doing? That makes more sense.
2 things. Come here.